Imagine a world where simple infections can no longer be treated, where antibiotics stop working, and everyday illnesses become life-threatening. This isn't science fiction. It's already happening. Drug-resistant bacteria like MRSA and gonorrhea are killing more than 1 million people every single year. But now, artificial intelligence may have just changed the game. Antibiotics have saved millions of lives since penicillin was discovered in 1928, but overusing them has created a dangerous side effect. Bacteria are evolving faster than we can create new drugs. For decades, pharmaceutical companies have struggled to discover new antibiotics. The pipeline has almost dried up, while resistance keeps spreading. That's why researchers at the Massachusetts Institute of Technology, MIT, turned to artificial intelligence. Instead of searching through libraries of known chemicals like older studies, they gave AI the power to design brand new antibiotics, atom by atom. The AI was trained on the chemical structures of known compounds, learning which ones slowed bacterial growth and which didn't. Then it was challenged to create fresh molecular blueprints, not just variations of existing drugs, but entirely new possibilities. The system tested two approaches. First, it searched through millions of tiny chemical fragments and pieced them together like Lego bricks. Second, it was given free rein, generating brand new molecular designs from scratch. The AI also filtered out any designs that looked too similar to existing antibiotics or that might be toxic to humans. After millions of possibilities, two molecules stood out. When manufactured and tested in the lab, they killed dangerous strains of gonorrhea and MRSA, bacteria that are among the most drug-resistant threats in the world. In animal trials, the results were just as promising. Professor James Collins from MIT called it a potential second golden age of antibiotic discovery, where AI helps us outsmart bacteria and rebuild our arsenal of life-saving drugs. But before we get too excited, there are hurdles. These new compounds aren't ready for people yet. They need at least 1 to 2 years of refinement before even entering clinical trials, and that's only the beginning of a long, expensive process. There's also an economic problem. New antibiotics are often used sparingly to preserve their effectiveness, which means they don't generate huge profits. Without financial incentives, many companies hesitate to invest in developing them. Still, this discovery shows the power of artificial intelligence to accelerate medical breakthroughs. Instead of spending decades on trial and error, AI can create and test designs in days, giving humanity a fighting chance against superbugs. We may be standing at the edge of a new era, one where AI helps save millions of lives by inventing the drugs we so desperately need. The battle against antibiotic resistance isn't over. But with science, technology, and human determination working together, the future may be brighter than it seems.